Very good morning, good afternoon, good evening my dear friends. This is the second lecture as you can see on the data analysis and decision making, which is basically the first part of the 3-part series for DADM, and we are considering different concepts of data representation as the frequency and non-frequency part. And this would be the second lecture in the NPTEL MOOC series, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we are discussing the frequency of the line diagram type. So, again I am giving the same example, which is the fertilizer consumption in metric tons starting for Andhra Pradesh to Assam for the year 1999 and 2000. Now, the frequency data diagram representation can also be done in the bar diagram, the histogram type. See, for example, we have the world population starting from 1950 to 2000, and the population is given along the y axis, and the year 1950, 1960, 1970, 1980, 1990 and 2000 given on the x axis, and the height of the histogram basically gives you the value of the population or the total population. Frequency data or bar diagram can also be represented as a horizontal one, or that the initial one was the vertical one, is a horizontal one. We have again in this case the population values are noted down along the x axis, while in along the y axis you have the year starting from 1950 to 2000. The third way of trying to describe the bar diagram in the histogram representation can be GDP in US dollars for the year 2002 for the number of countries. So, the number of countries are represented along the y axis, and the GDP on the number of countries as a block, as a group, okay, is basically denoted along the x axis. So, if you see the histogram, the height, if it is number of countries is 10, it basically means the GDP in 1000 between 10 to 15,000 is given for 10 countries. If you see, say for example, GDP or 45 to 50 is basically for about 3 countries. So, if you see the height, that will give you the number of countries, and along the x axis you have the basically the grouping or the GDP in 1000 between values of, say for example, 10 to 15, 15 to 20 and so on and so forth. Now, if you consider the frequency diagram, bar diagram, but now we are basically slowly trying to collate or consider more than one set of information. So, consider that we have individuals Ram, Shyam, Rahim, Praveen, Saikat, Govind and Alan. So, we have the height and the weight. So, the height in centimeters is given along the y axis, and similarly the weight is also given in kgs along the y axis, but there is a different color nomenclature. So, the histogram which is white in color is for the heights, the histogram which is black red in color is for the weights, and if you see the Ram, considers he has actually about height roughly I am giving in words is about 170 centimeters and weight of about 60 plus, say for example 65 kgs. For say for example Govind, it will be on almost the same. So, it is about 170 centimeters as height and weight would be about 70. If I consider say for example Saikat, he is almost touching the height of 180, about 178, 177, and his weight is about 65. So, you can find that you can have 2, 3 or more than 3 variables which you can basically depict on the histogram, and you can compare them such that you can find out the comparative study of the variables for any individuals as shown in this diagram. So, this in the initial case it was vertical, now in this case is horizontal. We measure the same thing, height and weight, where the height and weight are now measured along the x axis and the individuals are measured along or noted along the y axis. So, frequency data representation or the pictorial diagram representation, in this type of representation we can represent the data more vividly, and in many cases it is the popular method of representing the data. Here a suitable symbol is first chosen to represent a definite number of quantities of units of the variable. Against each data observation, the symbol is represented proportionally, so that we can get the idea of the variable quantities against the data point, and number of such symbols which are being utilized in whatever proportions would give you the number of times you want to basically depict the quantum of the data. So, consider in this concept of frequency data representation, which is the pictorial diagram representation, it basically denotes the number of universities in the following states in USA. So, note each symbol all this pi symbol, consider this, the symbol will represent 5 universities. So, in Alabama you will basically have 1, 2, 3, 4, 5, 6 into 5. So, 30 such universities are there. If I consider Delaware, it will be about 5 universities. If I consider, say for example, the state of Kansas, it will be 6 into 5, about 30 universities, and so on and so forth. Next is an example of frequency data statistical map representation. If it is used, for example, and let us give the example here. So, we are interested to show that diagrammatically the regional seismicity for earthquakes in Alaska of all magnitudes which have been reported between the year 1960 to 2002. So, that means from 1st January 1960 to 11th of September 2002, the color coding has been utilized in this sense. Thus, if it is blue in color, it means the height or basically the depth at which it has occurred, the depth of the event. Height means basically from the level where you are considering the earthquake. If it is between 0 to 33, it is given blue in color. If it is 32 to 75 kilometers, it is green in color. If it is red, it is basically 75 to 125 kilometers, and yellow, it is more than 125 kilometers. The larger circles, or the circumference of the circle, diameter of the circle area, are basically given for on a Richter scale of 7, and for the values, the color scheme basically denotes the circle indicates the depth of the event as above, and the star indicates the location as on 3/11/2002. So, if you see the map here, this is the Alaska region. So, basically we have you can have the latitude and longitude, the circles, and to the area specific would basically depend that how vast the effect of the earthquake have been, and the color scheme would basically depend that at what height or what depth, I should not use the word height, at what depth the earthquake has happened. So, you can understand. So, if it is blue in color, red in color, green in color, you can understand both its intensity and at what depth the actual earthquake has happened. So, this is basically for the map of Alaska. So, obviously, you can do it for our different regions accordingly. It can be rainfall, it can be humidity, it can be, as I said, it can be, say for example, earthquake, and all these things can be measured. So, now we will consider the divided bar diagram representation. Consider we have the time spent in hours by a particular student who is appearing for the CBSE examination for the and he or she is preparing for the following subjects, which are mathematics, physics, chemistry and biology. We basically collect the students' preparation pattern for a 5-day period and want to represent the data thus obtained. So, in that case we would use the divided bar graph as illustrated now. So, in this illustration we have the days, which is Monday, Tuesday, Wednesday, Thursday, Friday, as I said is 5 days along the x axis. Along the y axis we have basically the hours, and we will consider the person is preparing about 7 hours daily. So, that basically is an assumption which we are taking, that the person, he or she is basically studying each day 7 hours. It can be different. So, even if it is different, we can represent it accordingly. So, if you see Monday, the overall the colored scheme are like this. If it is white, it is mathematics, it is horizontal line, it is physics, it is checkered lines, box 1, it is chemistry, and if it is red, it is biology. So, if you see that in a 7-hour scale, on the Monday the person studies 1 hour for biology, on Tuesday he or she studies 1.5 hours, on Wednesday he or she basically studies 2 hours, and on Thursday and Friday he or she studies 1.5 hours each for biology. Now, if you consider accordingly, for mathematics it is 1.5. So, I am going from Monday to Friday, it is 1.5 hours, 2 hours, 1.5 hours, 1.5 hours and 2.5 hours. So, the total sum for each day is basically 7 hours. So, obviously, if it is not 7 hours, it can be done on a proportional scales accordingly. Now, we consider the stacked column diagram representation. The method of depicting the data is almost similar to the divided bar graph representation, but here we represent the percentage wise figures for the variables of each data. So, if you remember just few minutes back or few seconds back, I mentioned that if the person is studying more or less than 7 hours, how it can be represented. So, this is the way. So, consider we are finding the consumption of in rupees for the 4 main categories of food of a family in the month of January to June, January, February, March, so on and so forth till June. Remember that the total amount spent for each month can be different. So, obviously, in January I may be willing to spend more on, say for example, on my total consumption. In February it may be less, March it may be much more, and so on and so forth. So, remember that the total amount spent for each month can be different. We depict the percentage wise consumption in food for the 4 categories accordingly. So, this is basically drawn horizontally. So, we have the percentage along which is from 0 to 100 along the x axis, and for the months which is given as January to June along the y axis, and the color schemes are accordingly. Rice is white, wheat is red, checkered one, box one is vegetable, cereals is slanted hashed ones. So, if you see the percentage wise consumption in rice is almost equal to 20% in the month of March, and while for the month of May it is the least, and similarly if we consider the consumption of cereals, it is basically the least in the month of March and maximum, almost maximum for the month of January and May. Now, we will consider the frequency diagram representation in the pie chart. So, when the values of a variable are given for a number of categories as in a spatial series, we may be interested in a comparison, in trying to find a comparison of the categories of series or the contribution of each category to the total. Here the proportions or percentage of various categories rather than absolute values of the categories are depicted, and they would basically be the principal subject of our study. So, consider this is the JMAT examination, which was the examination which was held by all the IITs in order to consider the students for the MBA program. So, now it is basically replaced by CAT. So, this is the frequency data representation on a pie diagram chart representation for the median marks in JMAT in 2003. So, there were 4 categories based on which the JMAT was taken. So, it was verbal, which is slanted from top right to the bottom left, quantitative is red in color, analytic is basically again slanted from left top to right bottom, and the data representation is done basically using the white one. So, if you consider that the data representation is definitely more than 1/4 of the total pie, which is 360 degrees. So, each sector or the set is basically 90 degrees. So, it is more than 90 degrees for the data interpretation part. Is a textual representation. In the textual representation of the data, we depict the information through text. So, let me read it, you will understand. Consider for the year 2004-2005, we know that the number of postgraduate students who have registered in different engineering courses at IIT Kanpur are as follows. The figures are 83 in aerospace, 88 in chemical, 139 in civil, 222 in electrical, 176 in mechanical, 115 in computer science, and so on and so forth. Given this data, we may be required to utilize the information to answer some of the queries which may be raised. Say for example, we may need to find out what is the total number of female students who are there in the different programs. We may be interested to find out that what is the total percentage in which department the percentage of students were the highest along the total group, and so or what is the total highest gate marks for the students who have entered different programs. So, we can utilize this accordingly. Now, we will consider the stemp leaf representation. The stemp and leaf representation is a quick way of looking at the data set. It contains the informations of a histogram, but avoids the loss of information in a histogram that results from the aggregating the data into intervals. The stem and leaf display is based on the tailing principle, but also uses the decimal base of a number system. In the stemp and leaf representation, the stemp is the number without its rightmost digit. So, which is the basically we will subsume under the leaf. The stemp is written to the left of a vertical line separating the stem from the leaf. Suppose we have the numbers as 105, 106, 107, 109, 100 and 108, then if we use the stem leaf diagram, it will be 10, which is the stem, the slash which will now denote the leaf. So, the leaves are 5, so it will be 105, next one is 6, it will be 106, next one is 7, it will be 107, so on and so forth till the last one which is 108. So, next frequency data representation is the box plot representation. The box plot is also called the box whiskers plot. A box plot is a set of 5 summary measures of the distribution of the data, which are basically the information which we will be studying later on, which is the medium, the lower quartile, the upper quartile, the smallest observation, the largest observation, and so on and so forth. So, if we see the diagram, it will be very rudimentary one I have tried to draw. The box would basically depend and the median value would be the value at which what percentage of the probability we are covering on the left and the right. We will come to that later on. The lower quartile and the upper quartile will be given by the leftmost and the rightmost, and the whiskers would basically extend on to the right or the left depending on the maximum value and the minimum value. So, just a methodology of our representation. The box plot representations are upper quartile and lower quartile will give you the interquartile range. X would be the smallest observation, which technically can be, this is not a sacrosanct number, it will be 1.5 into the interquartile range. Similarly, for the largest value it will be 1.5 in the interquartile range. So, the values of 1.5, 1.5 are for the case being utilized when we think it is a symmetric distribution. Obviously, if it is a non-symmetric distribution, the values would change. Values means 1.5 would be different for both the left quartile, left part and the right part. So, we will consider a few definitions. So, quantitative variables, it can be predicted by a number on which the arithmetic operations such as the averaging would make sense. Qualitative variables would be the ones in simply some attributes. It simply records a qualitative characteristics like good, bad, right, wrong, color wise, number wise, whatever it is. As already discussed, the statistics deals with measurements, some being qualitative, others being quantitative. The measurements are the actual numeric values of a variable. Qualitative variables could be described by numbers, although such a description may be arbitrary. Say for example, if we denote good as 1, we may be tempted to give bad as 0. It can be -2 also, -3 also, we do not know, but it is basically some judgment would be utilized, but it is obviously not always objective, some subjectivity would also be there. So, right can be 1, wrong can be 0, or if wrong is 0, right can be +3 also. So, depending on how we have been able to set up the problem, we will give numbers accordingly to the attributes. Next is the nominal scales or the scales of measurement. In this scale, numbers are utilized simply as labels for groups or classes. If you are dealing with a data set which consists of colors blue, red, green and yellow, then we may give numbers or designate numbers to the colors as blue as 3, red as 4, green as 5 and yellow as 6. We can state that the numbers stand for the category to which the data point belongs. So, it may be remembered that nothing is sacrosanct by the concept of the numbers which we give to the colors regarding the numbering against each category or the characteristics. This scale is used for qualitative data rather than quantitative data. Ordinal scale, so the second concept of the scales of measurements. In this scale of measurement, data may be ordered according to relative size or quality. For example, a customer or a buyer can rank a particular characteristics of car as good, average, bad, not so good, and while doing so he or she can assign some numeric values which can be as follows, like characteristics is good, give a score of 10, if it is average, give a score of 5, it is bad, give a score of 0. So, this 10, 5, 0 or whatever the number is also subjective, there may not be any actual theoretical objectivity in the ranking system. Scales of measurements is basically we will consider the interval scales. For the interval scales, we specify intervals in which as to note a particular characteristics which we are measuring and assign that item or data point under a particular interval depending on the data point. Consider by measuring the age of the school going students between the class 5 to 12 in the city of Kanpur. We may form intervals like 10 to 12, 12 to 14, so on and so forth till the group of 18 to 20. Now, when we have one data point, that is the age of a student, we put that data or that student under any one particular interval. Example, if the student's age is 11, we immediately put that student under the interval 10 to 12. Now, the next concept of scale of measurement will be the ratio scale. If two measurements are in the ratio scale, then we can take the ratios of the measurements. The ratio scale represents the reading for each recorded data in a way which enables us to take a ratio of the reading in order to depict it either pictorially or in figures. Examples of ratio scales are measurements of weight, height, area, length, volume and so on and so forth. Now, we will consider something of a more conceptual sense. So, we will consider the concept of population and then consider the concept of sample also. So, these were a very brief way, maybe I have gone a little bit fast, but these different ways of depicting different type of data in the frequency type and the non-frequency type. Now, whenever we are studying statistics, basically it means that we have a huge population or huge set or a universal set, and based on this we will try to basically understand what is the characteristics of the population, but the characteristics of the population may not be known to us always with I will not use the word certainty, but is not known to us in the sense that we may not have all the actual readings from the population based which we can draw some meaningful conclusions. So, obviously it would mean then what should we do? So, obviously we have to pick up a chunk from the population which will denote as a sample. So, this is what we are going to basically analyze. So, population consists of the set of all measurements in which the investigator is interested. For example, can be all the students in the city of Kanpur. The population is also called the universe. A population is denoted by the symbol n, capital N. While a sample is a subset of the measurements selected from the population, capital N, sampling from the population is often done randomly, such that every possible sample of n elements. So, the small n is basically sample size which I am picking up. So, every possible sample of size n will have an equal chance of being selected. So, if we see for example, if you have a box and which are marked from 1 to 100, consider that is the population. So, consider that chits are 1 to 100, each chit is only once. So, basically we have the population as 100 such observation. Technically that is a thought out experiment. Now, you want to basically pick up a sample and sample size of 10. Now, why it is saying that each has a possible being n elements will have the equal chance of being selected is like this, and let us basically go into detail. See for example, if I pick up the observation which is marked the chit 1. So, obviously if we pick up the chit 1 the first time, the probability is 1 by 100. Now, if we basically remove the chit, so hence the total population technically would now be not 100, it would be 99, and hence the corresponding probability of picking up any other chit basically now becomes 1 by 99. So, obviously if we say that what is the probability of picking up number 2, it is 1 by 99. Picking up a number chit number 55 is 1 by 99, but also see on the other hand, if I say what is the probability of picking up the chit 1, it is basically now 0 because that has been already removed. But now if we change the experiment in such a way that if we pick up the chit 1, note it down and again put it back in the box. So, obviously the population remains same. Technically it means the population is infinite such that the corresponding probability of picking up any chit still remains 1 by 100, such that if I again pick up and the number 1 comes, the probability remains 1 by 100. Now, this is basically known as simple random sampling with replacement, and without replacement obviously it would mean that the corresponding probability would start decreasing. But in the if you have a population which is infinite, then if you pick up chits with replacement and without replacement, the underlying distribution should not change. That is the basic main essence. So, a sample selected in this way is called the simple random sample or just a random sample. Example can be the students in Kendriya Vidyalaya inside IIT Kanpur campus. A sample would basically be denoted by small n. Now, what is tally numbers? By tally numbers we mean the tally which we give depending upon the number of times that a particular value or the variable occurs in the total universe or sample, and this tally numbers basically will give you in depending on the value, we will basically count the number of tally numbers and basically say what is the frequency of the occurrence of a particular value. Now, we will also consider, these are the definitions, also consider the concept of frequency, which is absolute frequency. By frequency, which is absolute frequency, we mean the number of data points which fall within a given class or for a given value in a frequency distribution. It means that it denotes the number of occurrences are happening of a particular outcome. We denote the frequency, which is the absolute frequency, by the symbol of small f suffix I, where I basically denotes the number reading. So, obviously if there are 3 different type of numbers, and if the chit has basically 100 such numbers occurring, 100 means 100 number such papers which are there, but the number occurring or numbers which are occurring is only 1 or 2 or 3. So, consider number 2 occurs 50 times, number 1 occurs 25 times and number 3 occurs 25 times. So, if basically I am saying the frequency of number 1 occurring, it is basically 25, frequency of number 2 occurring is 50, frequency of number 3 occurring is basically 25. So, that is why it will be f suffix 1 which is for number 1 is 25, f suffix 2 which is for number 2 is 50 and f suffix 3 which is for number 3 is 25. So, we will consider the concept of cumulative frequency. So, the cumulative frequency corresponding to the upper boundary of any class interval or value in a frequency distribution, and it is basically the total absolute frequency of all the values either of the less than type or the greater than type. What is less than type or greater than type? I am going to come to that within few minutes. Then the boundary for the class of the value would basically be given by the cumulative frequency. So, we denote the cumulative frequency of the less than type and the greater than type by the corresponding formula, which is, so this capital F, which basically so the capital F basically denotes the frequency of the less than type if it is this. So, obviously, that will be all the sum of all the frequencies for the values of I less than equal to n. So, this is the less than type value, and if I am denoting the concept of the greater than type. So, let me change the color. So, the greater than type would be denoted by frequency of capital F greater than n, which means for all the values of I which is greater than and less than n, and it will basically mean the summation of all the frequencies for all the values of I which are greater than n. So, that means if I am saying that the frequency of the number of ones are less than 1, it will be 25. If I am saying the frequency of numbers of less than 2, it will be 25 plus 50, but when I am saying the frequency of the numbers of greater than 3, so obviously it will be 0. If I am saying that is the frequency of the less than 2, it obviously it would 2, it will mean the only the numbers of 1 only, which is 25. So, consider the example. We have the following data related to the size and the numbers of 30 families in the city of Jaipur. So, they are given as numbers 2, 6, 3, 4, 4, so on and so forth till the number 3 and 3. So, now there are 30 families. Now, the question is how do we represent the data using the tally numbers of the frequencies or the cumulative frequencies. So, this is how we do it. So, on the leftmost column we write the number of families members which are there in the family. So, it can be minimum is 2 and the maximum is 7. So, if the tally numbers are given, so it means 3 which is the frequency for 2, number of members being a family is 3. If you are trying to find out the tally number for number of family members which is exactly 3, it is 7. For family members number of exactly 4 is 10, for 5 is 5, 6 is 4 and 7 size being 1. If I am trying to find out the frequency of less than type, it will basically be number of families which are less than equal to 2 is 3. Family members which is less than equal to 3, it will be 3 plus 7 which is 10. Family size of less than 4, less than equal to 4 would be families having 2, families having 3, families having 4 which is 20. So on and so forth till the last one which I want to find out is the family size having members less than 7, less than equal to 7 is 30. If I go in the other way around, family size of greater than that value, if it is greater than that value of n, so obviously it will just be the reverse starting from 30 to 1. So, with this I will end the second lecture and continuing the discussion more about probability, more of frequency, relative frequency, chance and so on and so forth, so that we will slowly go into the concept of probability. So, with this I will end the second class and hope that you will keep yourself abreast with the discussion. So, we will maybe going a little bit fast, but try to basically cover the initial topics in such a way that we have quite a lot of time trying to basically cover the concepts of multivariate statistics and so on and so forth. Have a nice day. Thank you very much.